I hope you are doing well. So today we're gonna solve the problem. It's a GFG problem of the day. Next element with greater frequency. It's a medium problem, and we're gonna solve it using Java language today. So if you see the question, it is given an array of integers. For each element, find the first element to its right that has a frequency, then the current element. If no such element exists, return -1 for that position. So if we begin on the code side, we are given an array. Let's take this array 2 1 1 3 2 1. So we are given an array 2 1 1 3 2 1. So it says that we need to find the array such that, like, from the right side, we need to find a basically an array. Okay, so we need an array. So the array should be like, it must be having the first element to its right that has a higher frequency than the current element. So over here, if you see, we need to find this higher frequency, right? So in this area, how we will be knowing that we have the higher frequency to its right? So for this, we will be taking help of a map, so which will be basically taking all these values and we will be storing into a map. So for this, if we create a map, and map would be a hash map, so we would be creating a hash map, and in that we would be having 2 1 3. So the value of 2 is 2, value of 1 is 3, and value of 3 is 1. So now we need to find the highest frequency towards the right? So how do we gonna solve it? If you look to the problem carefully, it's giving a pattern, and I hope you recall it. The pattern is the next greater element towards it right. So if we see, this is 1, right? So let me change the color. So on 1, this is 1, right? So towards its right side, do you find any number which is greater than its own frequency? No, right? So we'll be putting a -1. Okay, now comes 2. So we would be putting a -1 over here, and we will be pushing this number to the stack. So we will be having a stack also, and in this we will be pushing this number. We have pushed the number. Now we gonna have come to 2, and we're gonna check the frequency of 2. The frequency of 2 is 2, and that 2 of 1 is 3. So this current element frequency is less than that of a stack's frequency, the element in the stack. So in the stack we have element 1, and it has a frequency of 3, right? So in that case, we would be putting this value over here, and it would be 1. Okay, now this is done. We have pushed it. Now we'll be pushing 2 in our stack. This is done. And now if we look at 3, so basically we are iterating our loop from over here. I is going over here, and it will be going till over here, till the 0th index. Just a minute, yeah. So till the 0th index it would be going. So now I moves to over here. This is a I. So if we look at carefully, the frequency of 3 is 1, right? And that too of a frequency of 2 is 2, right? So we need to find having a higher frequency towards it, right? So if you see in the stack, 2 has a frequency of 2 and 3 has a frequency of 1. So we have the highest frequency of 2, right? So what we're gonna do is that we wanna take this value of 2 and we're gonna put it over here in our array list. Basically, if you see in the question, we are returning an array list, right? This is our array list which we are returning. So this is an array list in which we are putting our values. So you must be wondering, we are putting from the right side, right? So in an array list, the values would be put it from left to right. So basically it would be like -1, 1, 2. So in the final output, what we're gonna do is that we're gonna reverse this whole array list and we're gonna return it. So if you look at carefully, now for 3, the value would be 2. Got it. Now I moves over here. In this, if you see, I has a value of 3, okay, and 2 has a value of 2, and 1 has a value of 3, right? So if you look at carefully, so 1 has a value of 3, so it would be looking towards it, right? That does any element has a greater frequency than 3? I mean 1. So if no, then we would be returning a -1 over here. And how the -1 comes over here is that we would be popping out every element from the stack as it's less than, right, the current value. So we would be popping out every element from the stack. So we have done this. So our stack is empty. Now once the stack is empty, we would be putting a -1 over here that our stack is empty and we don't have any element. Now we iterate over here till 1 again, and we're gonna push 1 back into the stack. So we're gonna push 1 into the stack. So if we take this stack, so we have 1 over here now. Now I over is over here. So if you see, I is 3. So we still don't have any element which has a frequency greater than 3. So again we're gonna put a -1 over here. Now we comes to 2. So the moment we come to 2, if you see, it has a frequency in the stack. We have an element which has a frequency of 3, which is greater than 2's frequency, right? So we're gonna put the value over here as 1. So we're gonna push this element. Now our loop is done. We come out of the loop, we reverse our array, the array which we have got. So basically the array list which we have got would be like this: -1, 1, 2, -1, -1, and 1. So we're gonna reverse it, so it will become 1, -1, -1, 2, 1, -1. So if you want to check the answer, it's 1, -1, -1, 2, 1, -1. So the whole core logic over here is that we would be having a hash map, basically a hash map and stack. So basically what we are doing is that in the hash map we are storing the elements, and in the stack, like in the hash map, we are taking the elements and counting the frequency of the elements, and in the stack we are storing the elements. So the whole operation takes order of n time, because we are running a loop for n. Okay, so first we are storing the frequency, so order of n for that, and we are storing all the frequencies, and then using the map.get function to get the frequency, it would be taking order of 1 time, and we are performing operation on the stack using our whole array, so it would be taking order of n, so it would be roughly twice of order of n, running the constant, so the time complexity comes as order of n, and the space complexity would be the same. It would be order of n itself only. So back to the coding screen now. So we would be coding in Java. So if you see, first what we need to return an answer as an array list, right? So we would be taking an array list and we would be putting integer, it would be answer equals to new array list. Now what we need a hash map. We would be having a hash map, so we have created an hash map. Let's call it as map. So it's a new hash map. And now what we need a stack also. So we will be taking a stack. So we have taken a stack. So if you observe, we need to first calculate the frequency. So for that we will be using advanced for loop, which is integer value we take, or we can say for each loop. So we'll be going it, iterating it over, and we'll be using a map dot put value map dot get, or default value would be 0 or plus 1. Okay, so if it's not found, we would be putting a default value of 1 and with 0 and 1, and if it's found, then we would be adding plus 1 over to it. So this is done. Now what we're gonna do is that we're gonna iterate the R array integer I equals to, it would be, we'll be iterating from the end, so it would be array of length minus 1, I is greater than 0, I minus minus. So now what we're going to check is that if my stack, or what we can do is that we can put it like while my stack is not empty, and we're gonna check that if map.get stack.peak. So in the map.get stack.peak, what we having? So this would be taking the stack.peak, and it will be checking if this value, this particular value, if it's less than the current, right? So we would be removing the elements from a stack, so we would be popping it out. So there would be pop operation. So we would be checking if that element is less than map.get array of I. If it's the case, we would be doing st.pop operation. Else we will be checking if our stack is empty. If our stack got empty, so what we're gonna do is that we're gonna add answer.add -1. Okay. Else if it's not empty, so what we're gonna do is that we're gonna put answer.add stack.peak, the element which we have on the top of the stack. And at last what we're gonna do is you're using a collection Java framework, collections dot reverse answer, and at last you'll be returning the answer itself. So we have taken array, so in that hash map, and we have taken a stack, so in that we are putting the values. Now we are iterating the loop from the end, I minus n minus 1. We can write it as n minus 1 also in a variable we store it. Then we are running a while loop while our stack is not empty, and we are checking if our stack.peak frequency is less than that 2 of our current frequency. So we're gonna pop it out from the stack. If our stack gets empty, then we are adding the answer in the array list as -1, that the stack is empty or we haven't found the value. Else we are adding answer.stack.peak, the value, and we are reversing our array list, and then we are returning the answer. So if we compile it, okay, so we got one issue. Okay, so we need to put a less than equals to, okay, if it's stack.pop, if it's empty. Okay, so we need to check one thing more over here. If it's empty, answer.add -1. Okay, we are doing that. Yeah, sorry, so I forgot one operation, and that is in the loop we need to put an element also. Yeah, I just totally forgot this. So we need to push an element also, and that too is array of I. Yeah, so if we go over here now, so it would be taking, yeah, so that's the answer. submit it. Yeah. So yeah, it's passing all the test cases successfully if you see. So that's a pretty simple question. And if we check our expected complexity also, it's order of n and n. So yeah, that's all for my end. And if you have any doubts or something like that, you can tell me in the comment section and do subscribe it. Thank you.